All right, new day and another laptop that needs to be saved, and this time we have a Dell XPS 17. This is like the 9730 version, so it's like a 2023. It's not very old. This customer attempted to upgrade his SSD and in the process ended up damaging the motherboard. So the laptop apparently runs on battery, but it will not run off of any AC adapters. So something got messed up when he opened it up. We're gonna have to take a look at this together and see if we can get this figured out. All right, he said that it does run on the battery, but the battery's probably depleted at this point. Yeah, I'm not seeing anything. So let's plug in the charger and keep an eye on the power meter right here. And so it is negotiating the 20 volts. The way USB-C works is it will plug in at 5 volts, then it will talk to the PD controller, which is a power delivery chip, and negotiate up to 20 volts. And then the system will start pulling some current. And if you notice here, we're pulling only 0.02. That means that we actually have voltage going into the board, the PD controller is working properly, and then it is probably turning on the LDO, which is a linear voltage regulator that's always on when the machine's off. And that's what powers the EC chip. And the EC chip is an embedded controller, so it's basically just a microcontroller running a loop of code. That thing interacts with a bunch of GPIO pins that interact with the keyboard or the power button. So it's actually looking for the power button to be pressed. So we're going to press that button and nothing's happening. So this is just without opening it up. We're just kind of reading what we're getting on the voltage here. I could be off base, but we need to see what's going on. A lot of times what happens when someone is upgrading or opening up these laptops is they end up damaging by like prying parts off. And also on these machines, if you change out the hard drive, you can end up damaging something too, and I'll show you how. Let me get the bottom taken off real quick and I'll be right back. All right, so to pry these bottoms off, they are very tight, but you see how it just came off with just my fingernail? I didn't even need to actually use a pry tool. That means that this bottom's been off a lot. Usually what will happen is it will be on there so tight and snapped on there so tight, you're into putting pry tools in there. So I wanna look at a few different things because we can actually follow the clues. And I think I already see some clues. You ready? Look right here on the end of this heatsink. So this is going to be the main heatsink. You see a dent there, and then I see some dents underneath here. We can actually look at it under the microscope. Yeah, so this means that this customer is having a hard time getting this back cover off. So the way that this one snaps on is it snaps on from the back, but it looks like there was a pry tool put through the back fins here. Yep, here's some more marks and some more marks. So I don't really necessarily blame him because it is hard to get these off and you don't really know how it's supposed to open, but I can tell you right now that the way that they hook on is that these kind of clasp around the back. The back goes on first and then it snaps in the front, so you have to pry it open from the front. So it comes off in a hinge. And so prying the back will not do anything, so sticking through the back vents is a bad idea. What I've also seen on this model is you'll end up ripping a component over here. That's part of the AC adapter detect. There's also a couple components on the side here that will prevent the board from turning on. So we may have some ripped components here, but here's what I wanted to talk about. So whenever you're changing out the SSD on this model, here are the two SSDs, right? The battery plugs in here. And so if they leave the battery plugged in while you're messing with this, that's just asking for it anyway. But you see how the battery is actually on top of the SSD heatsink? And the only way to get it out is you have to either take the whole battery out, which is the right way of doing it, or you're trying to slip it out in just the right angle. Yeah, and here's another look at it. You see how it slips underneath here? So the battery is actually on top of the heatsink. And the only way to get this out is to kind of try to slide it out at an angle. So if you wanted to upgrade the SSD or add another SSD without removing the battery, then you end up sliding it and then you can touch all this stuff. And so on this board, the way it's set up is here's the power management chip. This is what handles all the power for the board coming in. So it's the main power rail. It's like 12.6 volts. That's all this stuff. But guess what's over here? 3.3. It goes to the keyboard connector. It also goes to the EC chip. And so you can end up burning out an EC chip very easily. So I've seen damage in this area from changing out hard drives on this particular machine, and it's because they took this off and then shorted out the board. So we're gonna look around and see if we see any damage there. But another thing is they just don't unplug the battery when they're doing this. So we're gonna unplug the battery before we do anything. I actually wanna take the battery out because we're gonna need to take this battery out all the way to access the hard drive so we can look around. Because they said the damage happened when they changed out the SSD, it's probably there's some damage around there and we'll see some evidence of that. But other than that, it probably could just be some prying issues going on where they're actually prying in the back of the board or on the side of the board. And so in order to figure that out, we're gonna have to take the entire board out. But let's just look around and see what we can see without having to remove anything else. All right, so the battery is out. Yeah, you can see it sitting on top of this heatsink and sitting on top of that heatsink. So by taking it out, that takes out that issue, plus it removes all the voltage from the board, so we're not worrying about having to blow out anything. Now, since the customer says that the machine works on battery and it just doesn't charge, I feel okay about the EC chip not having an issue. I mean, there still could be an EC chip issue with the charging because that is in charge of charging too, but I'm not super worried about it at this point yet. All right, let's get back under the microscope so we can look around. So here's SSD 1. I think he was adding a second SSD, so I would say SSD 1's not going to be where the issue is going to be. It's probably going to be an SSD 2. Yeah, I think his note said he installed it and then he took it back out. So here's SSD 2. And I don't see any physical damage here and any physical damage on this port and then over here. So I think we can move forward with the prospective idea that something got shoved in the side, right? Because we see evidence of that. So we'll have to remove the motherboard and we'll figure out which chip got ripped off and we can get that replaced. And hopefully this board will be up and running again. All right, and the motherboard is out. All right, so we can look around on the edge real quick. I want to see if we see any physical mar marks on the side. And we can look, I don't see anything there on that side. Let's look on this side. No, I don't see any damage there. What about the edge of this? Oh yeah, I definitely see some marks here. I see a few marks on the edge right there. Yeah, and I see some marks, oh, a lot of marks there. We're gonna go with this side being our main issue, which is gonna be on this side, which will be on this side of the board. And so I'm guessing we probably have some damage on this side of the board. This is just guessing here. We're just using our detective skills, right? Laptop repair is like being a detective. All right, so let's get under the microscope and take a look. Here are the USB-C ports. Well, I don't see any damage on right on this side. Usually it's on the underside. Let's look on this side. This is the 3 and 5 volt power rails. All right, let's just continue around. All right, there is Thunderbolt. Here's the EC chip right here. There's the BIOS chip. I'm going to take this piece of tape off so we can look underneath. We're just going to look for any ripped chips. So at this point, we're pretty sure that somebody physically damaged a chip on the board. And so I'm not worried about anything being blown for the most part, unless they shorted out something, but this all looks fine. Over here, I've seen these ripped off before, especially that one right there, the U4002. Both of those look fine. But the symptom we're having is more on the charge part of it, so we got to figure out why that is damaged. And we could just have a bad EC chip. And on this one, it's a pain to change out the EC chip. But we can do it. Okay, all that looked fine. So let's go ahead and do the top side physical inspection. This is where the power management chip is. And most likely the voltage is getting all the way over here from the PD controller. And then this thing is what's in charge of creating the main power rail. So we could actually have a blown power management chip. I do have more of these if we need to change that out. We did have a video where we had a shorted wire here, or you could tell that there was a short that happened right behind this thing. And that was after changing an SSD out. I'm not seeing any evidence of that on this one. Again, he said that he changed out SSD number 2, not SSD number 1. Let's see what else we see. There's the Wi-Fi card. Not seeing anything over here. There's SSD number 2. And everything else looks fine. I don't see any physical damage, which I'm very surprised of, actually. And let's look over here, because I've also seen this stuff get ripped off on this edge. But I'm not seeing any issues over here either. I'm actually surprised. So now we just get to kind of go through and diagnose. You remember things like this get complicated because if it was just a regular fault where the motherboard just failed, it's actually a lot easier to fix. But when you have these weird random faults because somebody went in there and did something and then caused something else to happen, it's just like not a normal fault. So it just makes it a little bit harder to fix things. And it's becoming a trend at this point where I'm having to fix a lot of boards that people were just working on themselves and then damaged themselves. So let's plug in the charger. We got to do some measurements. Let's measure around the power management chip real quick. All right, so we have our 20 volts. It's only 0.2, which is fine. We're in voltage mode right now. I just wanted to see what we're getting over here on the main power rail. Not getting anything. Let's see about these MOSFETs over here. All right, we got nothing over here. Let's go a little earlier in the path. I was assuming that we were going to get voltage all the way over there, but let's go over here and see what we're getting. All right, if we check on the power management chip, we can actually see that we are getting the 20 volts coming to it. And then what we need to figure out is if it's actually powering the chip or getting an ACN detect. And we're not getting any of the other signals that we need over here. We're definitely not getting the 5 volts here. All right, so I see the 20 volts, but we are not getting VDD. So this chip is not powering up. We are only getting 0.02 volts on VDD. Let me plug in the battery and see if this VDD comes up. I want to see if there's a short on there, but most likely we're just missing whatever that power source is to power up this chip, and then that should fix that if we can figure that out. All right, so I have the battery. I'm going to plug in the battery real quick. So now we can measure to see if we're getting VDD. And we still are not. I can't remember if this is actually supposed to power up this chip when it's running on battery or not. And then this battery, I don't know how to charge this battery. So let me grab a charged battery to make sure we have enough power. All right, I have a test battery here. Let's plug this in and see if we get a different reading. And so we're not getting anything on there. And now let's plug in the charger. And if we measure, so we're getting 5 volts on this line right here. And we're getting 20 volts there, 20 volts there, nothing here. And then I want to figure out what we're supposed to have here, because I think we're supposed to have something else. So 0.8. And these should be 3.3, I believe. Yes. All right, so we're just missing our 5 volt on the VDD, which is what powers this chip on. So without this chip powering on, it's not going to be able to charge the battery. It's not going to be able to function properly. And it doesn't power off the battery, apparently. What we need to do next is we need to figure out what produces that VDD on that power management chip, because without that VDD powering on that chip, it's not going to be able to do anything. So before we start trying to chase down why this isn't being produced, we should at least check to see if we have a short in this area, because it'd be interesting if we see a short on VDD. And we do, 1.4 ohms. That's definitely a short. It's not a dead short, but it is a short of some sort. So this will make it a lot easier to track down what's causing VDD not to be present. So there's something pulling down that power line. I don't know how he would have caused this issue, but we're gonna have to figure it out. So we're gonna have to use a low voltage and then monitor it under the thermal camera, and we'll just inject voltage there and then we'll see what gets hot. We could just have a capacitor, or we could have some sort of chip that got ripped again that we just didn't notice that's touching something else. So let me go ahead and get the thermal camera set up so we can proceed. All right, I got my thermal camera set up, and if you're interested in any of the tools I use in this video, I have them linked inside the video description. So what we're gonna do is I'm gonna start out and we're going to inject voltage, and I'm just gonna use my short killer here. So I'm gonna inject a low voltage, probably we'll start at 0.6 volts. It is 1.8 ohms or something like that, and so that actually is kind of high, so we could probably do a higher voltage. But some people might assume because it is a 5 volt VDD power rail, you can just inject 5 volts. Well, it could be shorted over to something that's sensitive, that doesn't want more than 1 volt, so you don't want to do that. So I usually just start out with something under 1 volt. So here we'll do 0.8 volts. And then we'll go to that location. It's going to be this capacitor right here, and then we're just going to monitor it under the thermal camera. And oh, it's getting hot right there. Is it that capacitor right there? Wow. Could be. The only way to kind of figure it out is because the thermal camera tells me where it is approximately. So I'm just going to put some alcohol on here, and we're going to look to see if the alcohol evaporates. No, I'm not seeing anything evaporating. Oh, the power management chip's getting hot though. So we might have an internal short in the power management chip. But I also saw this other capacitor over here. Let's see. Here, I'm going to up the voltage a little bit now that we know it's in this area. So we're up to 1.2. Up. Is it this one? Look right there at that capacitor. I mean, I know the power management chip's getting hot too, but no, it's just a power management chip. All right, so that's most likely bad, and yeah, and I guess the customer could have messed it up. SSD 1 is located right here, right? So maybe they were taking SSD 1, moving it to SSD 2, and then putting SSD 1 over here or something like that. You remember how these SSD heatsink cages come off? They're underneath the battery, and so it can very easily touch the power management chip. It's just right next to it, see? So it's a possibility. So let's go ahead and get that power management chip replaced, and then we'll continue testing. All right, so one thing we want to be careful of is we have a bunch of plastic components around here. So we have the SSD slot here, and we got the memory slot here. We're gonna have to use hot air to get this off. I'm gonna just protect all this with some Kapton tape as much as we can, and then we're gonna try to make sure we just blow the air away. So I'll put the board in a certain orientation that will make sure to blow the air away. So we'll turn it like this. That way we blow the air across this way, and then we'll just protect all this stuff. So this is actually a super thick 2 mil thick Kapton tape. I really like using this stuff. And we'll put some here too. We'll just take this little guy off. And then I'm gonna add one big piece across here too, just to be extra safe. All right, so we have it all protected, and we're just gonna be grabbing it like that. And we just need to make sure our air is on to protect our lungs. We're gonna add some flux. And this is a 9538CH, an ISL strip, so I have more of those. So I'm just trying to make sure we blow the air away from these plastic components. And so I'm doing 450 degrees C, 60% air. I'm gonna add a little more flux. We wanna make sure that this will flow and come right off. We don't wanna end up putting a bunch of heat here for too long. Okay, and we got it off. Chip orientation is fine because it puts a mark right here at pin 1, so we don't have to worry about marking the board or anything. It looks like our Kapton tape grabbed onto this capacitor and knocked it off, which I've seen plenty of times. So we'll put that back on. It looks like it knocked off some other components too. Look at all that. So this is the only problem with Kapton tape is sometimes it has some shrinkage whenever it's heating up like that. So we want to make sure we don't have any extra components on here. But we want to protect our, connectors, so we have to do this. Sometimes you can cut a little piece of like tin can or metal or something. So let's make sure we put all that back exactly where it goes. So this resistor, that resistor. And I just want to make sure these are lined up right, or else nothing will work afterwards. And then we'll put this back right here. Let's add some flux right here, and we'll see if we can set all this stuff right back down where it goes. Okay, that one laid down. And that one laid down. Now, I don't know if there was one in the middle, so we'll pay attention. I'll have to check on a donor board and make sure that we have that set up correctly. But I think that is correct. Now we need to put this capacitor back on. There we go. Now all this stuff got knocked off because this Kapton tape, when it heats up like that, it starts to move or flex or whatever, and all the components are supposed to be held in place by the surface tension, and it just kind of dragged them off of there. It is avoidable, but it's also unavoidable if you're trying to protect things and you're trying to work in such a small area. So, all right, let's put some fresh solder on here, and that way we'll be ready to install the new chip. All right, so this was a 9538CH, so I have new ones. I believe they're about $8 on Mouser. So this is the new chip, and you have some solder on the board, and then there's no solder on this. And so if you're transferring a chip from another board and you have solder on both sides, it makes it very easy to set it down with the right amount of solder. But because we only have solder on this side and we don't have any on here, there's not gonna be enough solder, so I wanna pre-tin this ahead of time, okay? So we don't need much. I'm just going to put a little bit on my iron. I'm going to hold it in place. And we're just going to hit these outer pads. The middle's not that big of a deal. It's just the outer pads are what we're trying to make sure we have enough so we can make good contact. All right. And we're not really worried about them touching or anything like that, because when we reflow it, the solder's going to melt properly and spread around. Perfect. Okay, so you see the dot? So the dot's going to line up with that arrow right there. And we'll get it lined up perfectly. There we go. Let me put a little bit of flux under there. All right, and so what we're looking for is it to sit in place, which is doing perfectly. Now I'm going to let it cool off for a second, and we're going to apply a little bit of pressure to make sure we squeeze out any extra solder, and that way we make really good contact. Okay, and you see how that solder ball came out the side? That was the extra solder that was on the main ground pad, and we're just going to pick that up. All right, so we have that installed. I don't have it all the way clean, but what I want to test for right now is I want to see if that short is gone, and it was this right here. All right, and so the short is gone, so most likely we should get our VDD to come right back on there, and that should fix up everything. Let me remove the rest of this, and we'll finish cleaning up. We don't want to leave any of this flux on here because it dries and looks ugly. We like a nice clean repair. Just a happy little repair, like nothing happened. Okay, much better. And if you notice, see how this was protected and this stayed protected? This might have melted a little bit, but that just might be some of that alcohol that's still on there or some flux. But this plastic stayed good and that's stayed good. So all of this is perfect. Oh yeah, we wanted to double check and make sure we had all this in the right position. Let me grab our donor board. Here's our donor board. We got two outside ones and then the middle one is missing. And that's the same setup on this one. And then make sure we don't have anything else. This one's missing and we got those three. This one's missing and we got those three. So we're good. Okay, so let's figure out if we are getting our VDD. And the easiest way to actually figure that out right off the bat is if we plug it in and it starts pulling current, then we know that we're all set. So I'm gonna plug it in and we're pulling 0.1, 0.1, and then 1 amp. So we're actually, it jumped up to an amp for a second, so we know that that power management chip did power on and started sending some voltage where it needs to go. So let's go ahead and get this whole thing reassembled and then we can test. All right, I got the motherboard reinstalled. Moment of truth, let's see if it's working. All right, we're gonna plug in the power. Keep an eye on the power meter here. 0.06, 0.9, 0.1, that's good, that's a good sign. Is it gonna jump up? I see a charge light, I saw the Dell screen for a second. All right, and it shut back off. Is that okay? It's probably gonna go through a CMOS reset because we did have the battery unplugged. All right, we do have the Dell screen, and it was at 20 volts for a second, and then it shut back off again. So that's not good. So 20 volts, it went down to 0, came back on, and now it's blinking. So it's like we're showing a charge light, 2.3 amps. It's charging at 2.3 amps, but let's power it on. Is it gonna work? 4 amps? 5 amps? I mean, this is good. What I'm gonna try to do is we're gonna try to get in the BIOS so I can see if it's showing us charging, and then we're gonna have to go into the diags and make sure that the charge current going into the battery and charge current coming out of the battery is proper. But this is taking a long time, so I am kind of worried. All right, it is just hanging here. Let me turn it off and turn it back on, see if we can get it to do something. Now it's not responding. This is not good. Okay, 0.2, we'll plug it, turn it back on. Now he did say it worked afterwards on battery only, so it should technically not have any booting issues. It was just a charge issue and the power management chip was not powered on. Okay, I'm gonna let it sit here and I'll be right back. All right, let's give this another try. I let it sit here for a little while and the fan started spinning up, but I'm not sure what the issue is. All right, we finally got this. Okay, it was just a CMOS reset, it just took a long time. I mean, it took about 5 minutes. I don't know why I had to go through this full process here. So let's go ahead and boot into diagnostics. And I'm gonna run full tests in a second, but I wanna make sure that our charger is showing up properly. And we are showing that we have a 130 watt charger being detected. It says it's in charging mode, and it says that we have current flow of 4 amps going into the battery right now. If I unplug the charger, I wanna see that it has current flow coming out of the battery. So it's still stuck on charging. It shut off. Let me let this battery charge for a little bit because I don't think the battery's charged up enough for it to switch. So I'll come right back. All right, I let this charge up for a little while. We're up to 7%. So now I can unplug it. I want to make sure that we can run off the battery just fine. Shows that the battery is low because we got an orange light, but we are pulling 3.7 amps out of the battery. That's what we want to see. And we did switch to discharging. And when we plug it back in, it should switch back to charging and detect the AC adapter and put some current in there. The AC adapter detected, it's in idle, and then that should switch to charging. Takes a second to negotiate, and then charging, we have 4 amps going in. So everything's fixed up on this machine. The customer did not send the second hard drive that he was installing. He took it back out, so I'm gonna have to send back his laptop without having that second hard drive installed, and he's gonna have to install it himself, but I'm gonna go over exactly what to do. And on this machine, all you need to do is make sure you remove the battery completely out of the system. That will remove the power, and it will make it so you can take those heatsink covers off. I'd love to know your thoughts on this one, and thanks for watching.
I saved another laptop!